Buenas tardes, nosotros somos el equipo 3 y esta es la práctica 4, la última práctica de determinación de proteínas por método de Kjeldahl. Y esta es la única práctica que haremos en laboratorio virtual, ya que no contamos con el equipo ni con los reactivos necesarios la, para este método. Así que procederemos a hacerlo en el laboratorio virtual, al cual nos estamos dirigiendo ahora.
Hi there, welcome to the Kjeldahl method simulation. Here you will learn about how to determine the protein content in food, and how to use
Y vamos a tener a la mano
LCMS to look for specific
nuestro cuaderno
compounds.
porque necesitamos anotar varias cosas.
This simulation uses voiceovers. If you don't have audio, click the speaker symbol on the top right of your lab pad to switch the play mode. If you disable the sound effects, the lab pad will slide up whenever there are instructions to read. Click Continue to start your mission. Using the lab pad is an important way to get the most out of this simulation. Is this the first time you are playing a Labster simulation? Perfect, then let's get started with your first mission. Go to the meeting room. You'll get there by clicking the door behind you. Talk to the Food Authority representative.
Hi there, I'm Sam, a representative from the Food Authority. Nice to meet you. We have received 3 milk powder sachets here in the lab. They are from batches from 3 different producers and will be shipped to stores around the world tomorrow. We need to determine the protein content of these samples, and check that it matches the content declared on the labels. We will perform the analysis of each batch in triplicate, so we also get an idea of the variation of our method. I've assigned one of the replicates for batch 2 to you, so when you're
Pick up the milk powder batch 2 sachet and continue to the lab. Put the milk sachet on workbench 1.
¿Cuál será esta?
Put on a lab coat.
Montan las batas.
You will analyze the milk powder using the Kjeldahl method, a commonly used approach to determining the protein content of foods. Before we begin the analysis, let me show you how it actually works on a molecular level. Grab the VR headset. We start off with only concentrated sulfuric acid. Let's add a food sample. Here you can see a protein that was part of the food sample. The mixture has turned dark as carbohydrates from the sample are dehydrated to become like charcoal. Let's change the protein to its amino acid. During the heated acid digestion, the sulfuric acid oxidates the amino acids into their constituents. The gases SO2 and carbon dioxide form and evaporate out of the solution. All the amino acids have now been converted to NH4+, carbon dioxide and water. The sugars have been fully degraded as well, and the solution, therefore, turns a bright blue from the copper sulfate in the Kjeldahl tablets. It's now time for steam distillation. Try to notice what happens with the nitrogen molecules. Did you spot it? Because we increased the pH by adding the strong base sodium hydroxide, NH4+, changed to NH3, which is volatile. And sulfuric acid changed to sulfate. Hot steam will now distill the ammonia out of the solution. We have entered the acid trap now. The nitrogen ended up here in the distillation process and was trapped as ammonium ions in the acidic solution. When ammonia was trapped, the boric acid that was used to make the solution acidic was converted to tetrahydroxyborate, the boron atom is shown in pink. AP The added H+ ions from hydrochloric acid reacts with the tetrahydroxyborate to form boric acid, which works as a buffer. When all the tetrahydroxyborate has been converted to boric acid, the pH drops drastically with the next drop of hydrochloric acid solution, and the indicator changes color to a light pink. That's it. Let's return to the lab. Let's see if you understood the main points of how this. What form is the nitrogen in the food sample converted to in the acid digestion step? No, this is incorrect. Please try again.
Demonios.
Indeed, the protein is completely broken apart during the acid digestion step, freeing up the nitrogen as ammonium ions. Why is the mixture made basic after the digestion? No, this is incorrect. No, this is incorrect. No, this is incorrect.
No puede ser.
No, this is incorrect. No, this is incorrect. No, this is incorrect.
Todas están incorrectas.
You got it. All right, let's get started with the Kjeldahl method. First, you need to weigh the sample. For this, we use the analytical balance, where we can get a precise measurement. Homogenization will not be needed for a milk powder sample, but for other examples such as meat, it would be necessary to make the sample uniform before measuring. Take a piece of weighing paper and place it in the analytical balance. Now reset the analytical balance by first closing it and then clicking T. Pick up the spatula.
Un poco difícil voltear sin mouse.
Pick up some milk powder and place it on the paper in the balance.
Así que hice.
Click on the lab pad for more information. Great. You weighed off 1.0017 gram milk powder. That's within the range of what we need for the analysis. Now let's prepare the sample for the acid digestion. Return the spatula to the glass beaker and put on a pair of blue gloves. Pick up the paper and sample. Go to fume hood 1. Place the sample in the Kjeldahl digestion tube. Add sulfuric acid to the Kjeldahl digestion tube. Place the Kjeldahl digestion tube in the holder. You also need to add a few tablets. The Kjeldahl tablets contain a copper 2 salt, which works as a catalyst for the digestion, and also a sulfate salt, which increases the boiling point of the mixture. The other tablet works as an anti-foaming agent. Add the Kjeldahl tablet and the anti-foam tablet to the digestion tube. Good job. We're now ready for the digestion. Take the Kjeldahl digestion tube to fume hood 2. Place the Kjeldahl digestion tube in the digestion unit. Nice. The heat block will heat the mixture to a rolling boil at about 370 degrees Celsius, which will completely break down the proteins in the food sample. Normally, this would take about 1 to 2 hours, but let's speed up time to avoid the wait. Remember when all the gases went out of solution in the animation earlier? Some of these are toxic and really bad for the environment. The gas trap and scrubber system to the left of the heat block makes sure these are caught and neutralized. I believe the digestion has now finished. Click the acid digestion unit to disassemble it again. You should now allow the Kjeldahl digestion tube to cool to room temperature before touching it. Let's speed up time again for just 30 minutes instead of waiting. Pick up the Kjeldahl digestion tube. Go to fume hood 1. You now have to dilute the acidic mixture with water. Put the Kjeldahl digestion tube in the holder and pick up the graduated cylinder which contains water.
No puede ser.
How would you want to add the water? Exactly, well done. I've gotten the ice bath for you. Do you want to see what happens if you had added water incorrectly?
Sí.
If you pour the water all at once, you risk that the acid
Acidoso.
splashes up onto you or anything else nearby. Put the graduated cylinder back. Nicely done with the water. Now why was it that you weighed out the milk powder sample very precisely on an analytical balance? Exactly. The protein content determined can only be as accurate to the level of precision used for weighing out the sample. Do you recall what happened to the Kjeldahl tube when the digestion unit was done? Well remembered. The tube was very hot after the digestion. An alternative to letting it sit in the unit can be to put it in a holder and use crucible tongs to move it. So that was the acid digestion. What do you want to do next? Right on. Let's continue with that step then. Take the Kjeldahl digestion tube to fume hood 3 and place it in the distillation unit. The steam distillation unit allows automatic addition of 32% sodium hydroxide, and distills the mixture by blowing steam into it. A condenser catches the fumes and directs them into a boric acid solution. We call this solution an acid trap. Now it's time to prepare the acid trap, which will catch the distilled ammonia. Change gloves back to the normal blue ones. Prepare the acid trap by adding indicator solution to the boric acid solution. Click on the lab pad for more information.
¿Por qué no puedo? Me deja agarrarla. Pero vamos a ponernos los otros guantes, a ver si sí. Pues el... ¿Por qué no me deja? Qué tonto.
Place the acid trap in the steam distillation unit. Add sodium hydroxide solution to the Kjeldahl digestion tube. Start the distillation. Nice. While the distillation takes place, let's see if you remember what this part of the analysis does. Before the distillation starts, the unit automatically makes the solution alkaline with sodium hydroxide to convert what?
Ay, no sé.
No, this is incorrect. You got it. Volatile ammonia is formed by the sodium hydroxide addition. Ammonium plus hydroxide. Watch what happens while we speed up time to finish the distillation. The distillation is now complete. To make sure all the nitrogen is included in the acid trap, you would normally make sure the unit's condenser is completely empty at this point. Our virtual instrument is so good we don't need to do that though. Open the steam distillation unit by clicking off. Take the acid trap to workbench 1.
Ahora el otro.
Click on the lab pad for more information. Place the acid trap on the heating plate, and add a magnetic stirrer to the acid trap.
Caracoles para calentar. No veo nada. Creo que sí era el otro.
Click on the lab pad for more information.
Oh, lo enciendo.
In the titration, the burette is already set up for you, with 50 ml 0.10 molar hydrochloric acid. The titration is completed when the color of the acid trap changes back to pink. Check out the theory pages if you want to know more about the chemistry that's going on. Remember to turn on the magnetic stirrer before you begin. Turn on the stirrer, and click the burette to start the titration. Nicely done. The volume of 0.10 molar hydrochloric acid used was 30 milliliter. This number is important to take note of, as it's our measurement that represents how much nitrogen there was in the sample. You now need to calculate the nitrogen content in the milk powder sample, based on the titration result. For each step in the calculation, I will suggest several equations that could be used, and you need to choose the correct one. If you encounter a symbol that you're unfamiliar with, just head to the theory pages, where I've made a handy overview for you. Are you up for this? The moles of acid used in the titration, N, is found by No, this is incorrect. Please No, this is incorrect. Exactly. The amount of hydrochloric acid used, N, is found by multiplying its concentration with the volume used. So you used 0.0030 moles of hydrochloric acid in the titration.
Vamos a verificar. A ver, ¿cuánto es? 0.10. Está bien.
The moles of nitrogen present in the original sample, NN, is equivalent to No, this is incorrect. No, this is incorrect. Sweet. Hydrochloric acid reacts 1:1 with the boric acid that was converted to BOH4 when NH3 was trapped as NH4+. So in the titration, amount of ammonia equals the amount of hydrochloric acid, which equals 0.0030 moles. As we have retained nitrogen quantitatively throughout the analysis, this amount should be equivalent with what was in the sample you took.
que es el mismo que el de ácido clorhídrico.
Finally, we need to find the percentage of nitrogen in the original sample. Which of these formulas should we use for this?
Creo que es
No,
esta.
this is in.
No, entonces es la otra.
Good job. The correct calculation is then as following, so there was 4.2% nitrogen in your milk powder sample. We're not looking for the nitrogen content though. We need the result expressed as the percentage of protein in the milk powder. This is done via a conversion factor between nitrogen and protein, based on the average nitrogen content in protein present in the analyzed food source. Look at the table below. What conversion factor should you use for the milk powder samples?
Sí. ¿Por qué no? Sí. De la milk. Que 6.38.
Well done. We can now calculate the protein content in your sample. Percent protein equals percent nitrogen asterisk times 6.38 equals 4.2% asterisk times 6.38 equals 27%. Alright, the results are also ready for the other samples. Let's see how it looks overall. This table shows the protein content in the sample you've analyzed, as well as for the other two samples we've received. You can see the standard deviation of each determination, based on the triplicate measurement. Let's go report our findings to Sam. Go talk to Sam in the meeting room.
Y bueno, creo que esto ya es todo. Sam.
Click on Sam to speak with him.
Nice work with the Kjeldahl method. It looks like your results match the declared values within the accepted error of the method. We just got a tip that one of the batches might have been cut with melamine. We need to clarify this immediately before the product is shipped. It's imperative that we catch any adulteration before the product reaches the consumers. Back in 2008, there was a big scandal in China, where melamine was found to have been added to milk powder used for infants. Can you help make sure this story is not repeated?
Check out the material about the melamine scandal in the meeting room. When you're done, go back to the lab to discuss this new information with Dr. One.
Vamos a ver lo de la melanina, perdón. De feas personas. A ver qué dice de los bebés.
Click on the lab pad for more information. I will have the 3 milk powder samples sent for LC-MS analysis right away. This technique can detect any melamine adulteration. Meanwhile, let's explore why the Kjeldahl method didn't catch any melamine.
Okay.
Go to the hollow table. Check out glutamine by clicking the button. Here you see glutamine, an example of an amino acid. In the acid digestion, amino acids are broken down into their elements. As you know, the nitrogen ends up in the form of ammonium ions. You can check out the structure of an ammonium ion as well. Check out the structure of the ammonium ion. Then click the melamine button to continue. Here you see melamine. The nitrogen in melamine also ends up as ammonium ions during the acid digestion of the Kjeldahl method. This is why we can't detect it. Combined with the high nitrogen content in melamine, this is how cutting milk powder with melamine can make it seem like there's a higher protein content. From our results, would you suspect that one of the samples has been adulterated with melamine, and if so, which one? Remember, you can check out the protein results in the Media tab. Interesting guess. Let's see what the LC-MS analysis will reveal. When the samples have been tested by LC-MS, you will have to interpret the results. Let me bring you up to speed on LC-MS and how this interpretation is made. Go to the display on the wall. Liquid chromatography tandem mass spectrometry is a sensitive and selective analytical technique, which is very powerful when you want to detect and quantify extremely low amounts of e.g. organic compounds. It employs 2 separate techniques. The LC technique separates the different compounds in your sample. The separation happens as the dissolved sample flows through a column packed with a material to which the sample components have differing affinity. After the column, the flow is directed into the mass spectrometer. Here, the sample components are ionized and guided through a pair of so-called quadrupoles, which selects for whichever ions you want, based on the mass-to-charge ratio. Between the 2 quadrupoles, the ions go through fragmentation. As you can look for a specific fragmentation reaction, also called a transition, this technique is both very sensitive and very selective. Did you get it? So retention time is an important feature when assessing. No, this is incorrect. No, this is incorrect. No, this is Exactly. By comparing with a standard, we use the retention time of a peak as one of several measures to ensure that we're looking at the correct compound. For melamine, we will be looking for the fragmentation reaction 127 to 68. This means that melamine is first ionized into the precursor ion 127, which is known to fragment well into the product ion 68. It's this product ion that's actually then. In this type of mass spectrometry, we will look at the so-called chromatograms that result from fragmentation in mass spectrometry is used for. No, this is incorrect. You got it. Both of the peak area is an important feature when determining. No, this is No, this is incorrect. Awesome. Peak area is indeed linked to the concentration. Here you can see the results from the LCM-SMS analysis. 3 recovery controls were prepared to also get an estimate of the variation. Each had a spiked concentration of 1 microgram per gram. A blank milk sample, called a matrix blank, and blank solvent sample was also prepared as negative controls, and a set of 7 standards was prepared for calibration. You will only see a subset of the standards though, representing sample concentrations of 0.25, 1.0 and 5.0 microgram per gram, respectively. Check out the chromatograms. Interact with the lab pad when you're ready. Before we look at the samples, you need to make sure you can trust the method. I will give you a few important things to check for. Look at the chromatograms of the standards and blanks. Are the blanks in fact without any relevant peaks? Exactly, the blanks indeed look blank. The higher noise level in the matrix blank is expected. Now compare the chromatograms of the recovery controls with those of the standards. Does the retention time of the peaks in the recovery controls align with that of the standards, and do the recovery controls seem to be within the range covered by the standards? No, this is incorrect. No, this is incorrect. No, this is Nice. There's an extra peak in the... I have prepared a calibration curve with the standards using linear regression. It has the following form. Peak area equals A times concentration plus B. How would you use this to calculate the recovery? No, this is incorrect. You got it. The top 3 rows show the calculated concentration for each recovery control. As you suggested, we now take the mean value and determine the standard deviation. The relative standard deviation, RSD, gives an estimate of the precision of the method. Below, great work. We can conclude that the method is reliable, and we can proceed to determine if any of the samples were cut with melamine. First, I want to be sure you understood the essentials though. What is recovery in a chemical analysis as LCM-SMS? No, this is incorrect. No, this is incorrect.
Ahí no es
Exactly. In other words, it's an estimate of how much analyte the method recovers. What is a control in analytical chemistry? No, this is incorrect. You got it. I now need you to check the chromatograms of the samples. Check out the sample chromatograms. Interact with the lab pad when you're ready. From the chromatograms, which sample could have melamine contamination? You nailed it. There's a clear peak in the We need to make sure this peak is within what we can detect with the method, to firmly distinguish it from noise. There are several approaches to this, but here, we will use the lowest standard, which has been valid. Right on. The peak areas are using the same approach as with the recovery controls. We can now calculate. I will send the results to Sam immediately so he can take action. Before you go and talk with him, let me test your understanding of protein determination with the Kjeldahl method one last time. Why could the Kjeldahl method not detect the melamine adulteration of sample 2? Exactly. This is, how do we know that food fraud has been conducted for sample 2? No, this is No, this is incorrect. You got it. Go talk to Sam.
Thanks a lot for all your quality work. It turns out that sample 3 came from a company where
your score has been saved together with your 100% progress. Congratulations, you have completed the simulation. We hope you enjoyed it and you feel wiser now. Press exit to close the simulation. I gained relevant knowledge by using the simulation. I found the simulation motivating. I feel more confident about my lab skills after this. I feel that I can apply what I have learned in this. In general, I was pleased with. Thank you for your feedback. Please exit the lab by pressing escape. See you in another lab.
Adiós. Excelente. Bueno, esto fue la práctica 4. Todos los cálculos que hicimos los vamos a pasar al informe, digo al reporte, y también vamos a subir el video de todo el procedimiento a YouTube. Muchas gracias, profe.